All right, hello everybody, and we're learning things. Welcome on back. Sorry, I was just mentioning. So I did a video. I think it was about an hour long of doing the Sudoku solution validator, which was actually downgraded to a 6 or a 7. I can't remember. Actually, we can search Sudoku. Okay, it even pops up there. Enter. Yeah, the board validator was the one that I started doing, which is actually pretty lengthy. So instead, let's do some white challenges, which is the easiest challenge. Now to do that, you just filter here, difficulty to 8 Caillou. I think it's Caillou, I don't know, that's how and then there you go. And then it refreshes, and you can see the little load bar up there. Alright, so let's just pick random ones. The first one, sum of multiples. So, your job, find the sum of all multiples of n below m. Keep in mind, n and m are natural numbers, positive integers. Okay? M is excluded from the multiples. Alright, so sum mults of 2 to 9. So everything up into, but not including, and then you add them together. Wait, sum of multiples. So 2 times 2. What? Are you just adding it again? Yeah. 3, 6, 9, 4, 8, 12. Okay. So you're adding them, then adding them. Okay, so this was like something did way back in the pre-calculus class. But anyways, let's go ahead and train. Um, so what we're gonna do, so we have a start point and the multiple up until the max. So already I'm thinking like a while loop, like while, or no, in fact even that. Let's make a variable. So current equals n while current is less than m. Not less than or equal, and that's how you eliminate the, or wait, actually no, n, and then we're gonna do, as the second line, n plus, no, n equals n plus 1. I think you have to do it that way in Python. So in Java you can do n plus equals, actually let's see, n plus equals 1. Although for some reason I want to say like, or maybe this is the way you have to do it and you can't do n plus plus. Maybe that's what I'm thinking of actually. Yeah. Let's comment. Actually, let's comment that out. It'll be an infinite loop and then say like print done. So let's test it. N plus plus. Yeah, it won't let you even run because it's not a thing. Now, you can do plus equals, I believe. There you go. Done, done, done. So that's fine. So that just confirms, sorry, 3 times that, because there's the 3 test cases. Okay, so while n is greater than n plus equals 1, and then what we also need to do is current plus equals, wait, so now I'm thinking even another variable like diff equals n. So current plus equals diff, and that's it. And then what we want to do is, I think it's return current. Okay, let's try that. Plus equals, there we go. Okay. So let's look at this one. While n is less than, so sorry, what I'm thinking now is like, oh, and what's invalid? Sorry, I didn't finish reading it. So, oh, if it's invalid, so for that we could just throw in a check if m is less than or equal to n, return invalid. Invalid. There you go. So at least we'll pass a couple of tests. Yay. All right. So that's just if it's less than or equal to, because you notice the test case is a 0, 0, and a negative. So like, already, so those are invalid. But for this one, we needed to get to 20. So that means we're not doing it 2 times enough. So while n I want to look at the examples again. So 2, 4, 6, 8. So I mean, this is weird, but let's go ahead and try it. While current is less than m, 10. So okay, yeah. So that didn't even sound like, because current is the one that's increasing by diff every time. So it's adding. So for 2s, it adds another 2 every time. For 3s, it adds another 3 every time. For 4s, and so on. Like in the examples, you have a 2, a 3, and a 4. Oh, all the way up to that. But it's 4 plus 8 plus 12. So the first one, it's 4. So the current plus equals diff. Ooh. No. Because if it's 4, in fact, let's go ahead and change this to sorry, as I was saying that, you can change this to the ones, and then you'd want to change this as well. Wait, sorry, I was doing the exact same one. 13. Just to kind of get a different picture, and we're going to change this to whatever that one is, 30. Okay, so now the first test, 15 should equal 30. So we're not going far enough. And already let's change this back, because n is changing. And so, wait, that doesn't right. So 2, 4, plus 6, plus 8. So it really is the current. So you could do current plus equals n, and while no, see, it's still doing, so that actually does the same thing. So I just changed the logic around a little bit. So instead of, so you're adding n, so n is the unit that it's changing by. So it's changing by 2s every time. So that's why we don't even really need the diff. You just take that out. But current, so whatever it is currently, is equal to n. So the first one, we have 2 plus 4. Oh, right, running total. Jeez. Running total equals n. Wait. Plus equals current. Because we're actually, it's the 2 layers of, see, we're adding them all together. So I was finding the 2, 4, 6, 8 fine. And it was going to be, yeah, so let's do that. And then gotta do running total. Let's see what that gives us. Okay, so now, now we're going too much. And I think, wait. So if current plus equals n, n is the rate of change. So the first one, actually let's go ahead and just print current. I want to see. see what we're getting here. Just because, like, sometimes it's easier to see. So we have 6, 9, 9. Okay, so the current running total is 6 and 9. And that's supposed to be... Ooh. Let's try that. Wait a minute. Wait a minute. There we go. See, I was starting at too far. There we go. Okay, now we need to... And so, to explain that a little bit, I was setting it equal to running total. So I was already adding one too many. And that's why I was just like, oh, it just looks like it's just missing it a little bit. Okay, so let's go ahead and take these out. So this is a good method to kind of problem solve that. You could, do print statements to see, okay, and I just did that to see, which isn't the best. Like, it would really be better if I just did, like, well, I mean, in a hurry, this is good, because if you know the current and then the running total. So this is what's changing every time, because we want the running total to be the sum of all these things. You could do it other ways, like you could do like, my list equals an empty list, and then each time, but that's an extra step, and that's actually kind of complicated. I wouldn't even do that. Like, but what I'm saying is, like, you could add each one of these currents to that list, and then you could do another loop. But I mean, this is the more efficient way to just do it all in this loop. You always want to do it in the least amount of loops possible, because you got to remember, every line in a loop, the computer has to look at something or do something. So like this one, it has to be like, okay, so the CPU has to be occupied for that split millisecond or computer cycle or whatever to be like, okay, I make this calculation and then I do this. So you're still dealing in, like, nano or milliseconds in a lot of these situations, but you start doing like hundreds of thousands of millions of milliseconds, then yeah, then you're talking minutes, hours, days, whereas the more efficient code could do all of that stuff, in seconds. So anyways, all that to say, now we need to, I'll just comment this out. I mean, we'll control slash is how you comment all of it. Well, actually, no. Let's take that out, because we know that isn't needed. I mean, we have this video record of what I did try, but I do want to attempt and see if there's any before we start getting rid of everything, because I've done this before. This is actually what I saw when I did the Sudoku validator. Oh, shoot. Well, whatever. I declared, ooh, invalid should equal 0. Okay. So see right there, 0 is not a natural number for this kata, at least. Should work for n greater than m. Wait. What? Well, so this is also bad. Execution timed out. So that's interesting. Failed 4 plus. Oh, okay, so that's like... It should not include it. So I wish I could see... Oh, wait. There you go. I actually do Control Z. There you go. So those are still comments. They don't matter. Let's go ahead and see what's going on. So this is going to print a ton, and it's going to time out. Alright, failed. Max buffer size. Okay. It's still so... Oh, maybe this was a bad idea. Wait, what? I said if m is less than or equal to... Oh. I get it. If m, no, n equals 0. Return invalid. See, it's and let's actually comment this back out, because you'll just go on forever. Okay, that didn't take away the infinite loop, it doesn't look like. Or it still says, okay. Should work for invalid should equal 0? See, now this is an interesting corner case because, like, so we did get more. Notice we have passed 6, failed 4 plus, but we were at 4 passed, or even 2 passed, I don't know. But either way, we got more. So we're getting closer. Hmm. Should work for n equals m. Well, I mean, just. I mean, this could also mean that some of the test cases are just really large. So. Wait, what? Should work for n greater than m? Okay, I didn't even read the instructions at all. Of n below m. Uh, should work for if n is greater than m. I'm so confused. Invalid should equal 0. So is it only if m is less than 0? Well, let's try it. I don't think that's right, but maybe. I mean, ugh. Now this, I don't get this. And it looks like it says 1 plus, but it timed out. I don't know. This is just I should probably. Your job, find the sum of all multiples of n below m. Like, it's. I don't know. I feel like it's something stupid, like it's just less than or equal to, or something, like just kind of. No, and it's not changing this. Like, we are getting the correct answer for most of it. Like, we're past 9 tests. Basic examples, which we can't see from here. Let's see. 0 should equal invalid. So at some point, we're returning running total being 0. Um, uh, Alright, I'm gonna try this. Just because, and this is like hard coding. Like, I'm just reactionary coding. So if running total equals. No, this is hard coding. This is specifically coding return invalid. And no, this is not gonna work because I was gonna say else or elif do this, but we don't have to because this will end it. So whenever you return, you're ending it. Yeah, I don't think that's gonna break something else because they're gonna try to. If it was me, I would write a test case to test to see if it did an invalid for 0. See, should equal 0, and that's right. And I thought even for them, like, yeah. See, wait. If n equals m. No. Sorry, now I don't like this. Now we're getting into hacky things. Moving on. Let's completely abandon it. I don't know. It's already. I feel like it's sloppy coding. So basically, it's saying these tests are when n equals m, or when n is equal to m, meaning that what I could do is I could just do the simple tests and change this to mm, should equal 0. Let's see. I still feel like this should be if m is less than n, because then that's a more scalable way of saying, it could be 4 to negative 7, like if you're ever going backwards, because, I don't know, I feel like this isn't really well, I mean, look at the instructions. Find the sum of all multiples of n below m. Keep in mind n and m are natural numbers, positive. Oh, wait, n and m are natural numbers, positive integers. Okay. All right. So if or n is less than 0. Okay. Well, it's. Oh my gosh. See, no. Positive integers. So right there, this is trash. Invalid should work for. Should equal 0. This is all kinds of broke. Alright, now we're going to stop. Well, we're already 22 minutes in, and this is just. So every now and then you get a bad kata. Because just on this, keep in mind. So I think we were actually like on our way to solving it, just from my basic understanding of like adding up all of the sum. So adding up all of the multiples of n. So you take n, then you add it. So running total. And see, that's why I got confused, because if even saying that of all multiples of n, so you got n. Oh, I see. Plus equals current, because I set current equals to n. Gotcha. Okay, so I am initializing it as. Oh yeah, that's right. Because then we changed n later. Um, I also had to look real quick to make sure we weren't changing n, because I was changing n, and that was part of the problem. Or actually, we had to like change the logic and stuff. But like for here, because we're adding n to current, because n is just how much it changes. So if we're going by 2s, by 3s, by 4s, we're adding 2s, 3s, and 4s. So that's just what we're adding. N is what we're adding. Then, so like this, and we passed the basic tests, but then it's starting to really try to test them, but I don't think they tested them correctly. Like, 10 issues reported. But a few times I got one random error from about 100 random tests, one error per try, 1 time occur. So spoiler, spoiler. Hmm. Some other languages, correct solutions won't pass. Interesting. So, anyways, no, that's we got like 5 minutes or 6 minutes left. We'll leave this in here though. I will say like there's a lot of issues, but I don't know. Let's try to just find a random one. Try to find something easy. We'll still do difficulty 8 Caillou. Let it reload. Oops, gotta click out to reload it. And then, so we've done that. We've got a little. We've got a yellow one. I haven't noticed that before. All right, fake fight. Find the position. When provided with a letter, return its position in the alphabet. Ooh. Okay. I think we can do this. It's going to be a lot of typing, but so basically we're going to do a dictionary. So you're finding the numerical values. So my no, let's say like letter vowels for letter values equals, and we're doing one of those, and then A. Ooh, and there are easier ways to solve this, but I'm just doing it this one. 1, comma, and then control 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Just showing you how easy this is, because this is really important if you want to do encryption algorithms. You need to be able to create, so sorry, let's just keep going. I'm going to change these first to make them all the way up. And there are much cleaner ways to do this. So, and I say that because this is how you can actually understand encryption a little better. Like if you're assigning numerical values to something, then you can manipulate them a certain amount of times. So then 1, 2, 3, 4, 5, 6, 7, 8. Oops, 91. 9 and then 1. And I'm not even like looking at my keyboard. This is all just guessing. 21, 22. Oh, and then you don't want to start doing that. You also do the comma. That would have been a bug. Alright, and then 23, 24, 25, 26. 27? No, maybe I just did one too many. Okay, so now we gotta do B, C, D, E, F, G, H, I, J. I was doing with my left hand, and now I'm doing with my right hand. Like K, L, M, N, O, whoops, P, Q, R, S, T, U, V, W, X, Y. I did miss one. Z. Okay, I just didn't think that would be 27. Because there's 26 letters in the alphabet, so I think I did one twice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 21, 22, 23. See? You just get going, and oops, 24, 25. There we go. That, it's hard to see because it's all dark now. 25, 26. Okay, so return to return equals position of alphabet, and then to turn plus equals string cast of letter vowels and then of alphabet. There, so it's basically like, and then also let's do return to return. Actually, let's split that up a little bit. So basically what I'm doing there, let's go ahead and test and see if that's any. Alright, cool. So let's go ahead and do the test. So basically what it's doing is that's outputting. In fact, we could even say print. Well, no, we'll just, it passed the test, so you know it's saying this. So position of alphabet. Let's do the attempt. We'll go a little over 30 minutes because we're right there at 30-minute mark. But yep, C. So we did one in like 5 minutes. It was actually pretty good, and I do it this way. It is sloppy because it could be much shorter, but I prefer this way with the dictionary because then you can see like actually each one, and that's exactly what they're asking for is like what the function of a dictionary is. So if you have all 26 letters, which it is a bit cumbersome, we notice I did 10 on the first line, then I did enter to make it. You can do that with dictionaries, and that is something to good. I would even do. I mean, I kind of want to say take it a little further, but you know, like for the purpose of this, this is a nice, clean, simple way. And then what we're doing here is we're building a variable to return. So our first part, we take whatever this is, because we got, I mean, so then this is the input and then what's expected. So the output, what we're supposed to return to code workers, yeah, to the engine. But so we start building it with whatever they have. So this is easy. And then we have to cast it as a string. So we have to surround whatever this is. And so then let's look at this a little closer. So this is how you use a dictionary. So letter vowels, remember that's the name of our dictionary here. And then I want to get whatever this key is. So it's keyed off of alphabet. And the alphabet, remember, is the input here. So it's A, Z, E. And it probably goes through, yeah, they test every single letter. Wait, do they do it in order? No, it's like B, J, C, C, Z, V, T. I'm so confused. So, first thing I want to point out, we only did lowercase. So, had this challenge be testing uppercase, we would have to do something like alphabet dot lowercase. Or I forget what the Python is, like, oops. Um, you saw my computer. Alright, wow, that was embarrassing. Alright, Python to lowercase. Yeah, whatever. Dot lower. So what we would do is alphabet dot lower. And just show you. Doesn't matter because it's already lowercase, so we already got it. But this makes it scalable for if they were starting to feed us uppercase characters, because then it doesn't matter. And vice versa, if you built your dictionary with uppercase characters, you would then want to do dot two upper, but I just do dot two lower. I mean, that's even the test cases that they did, so I think that was part of why. I feel like it's more work to do it dot upper, but I don't know. But anyways, so this is the dictionary, and anything in the square bracket is the key that we're searching for, and that this will return because it's based off the search term or the search key. This will return the value. There's other different ways that you can use a dictionary by, like, so say we have the search value, but we want to return the key. There's a different way to do that. I mean, it's a little more cumbersome. I like to just make two dictionaries for encryption algorithms because then you can see, oh, an A is supposed to be a 1. And this makes it easy for troubleshooting when you have a bug because then, oh, it didn't become a 1 when I decrypted it. Let's take a look at the dictionaries. Like maybe this one was 1 based instead of 0 based indexing. So notice, like, my opinion, it would be a 0. And then everything else would be 1 less. And then the corresponding dictionary of the number vowels, or back to letters, would be that. So anyways, let's go ahead and submit this. I like it. It's good, clean. It's not the best submission, or I mean, well, actually, I'm glad we added this. So that makes it look like we understand a little more about sanitizing your data inputs. So if they give you a capital letter, or if they give you a duck, like, you got to account for that. So, but luckily I think Python does it. It'll error out. So we'll submit that. Okay, a little bit. We took as long talking about it as we did doing it. So, anyways, and now we can look at all the other stuff. Oh, test cases. We can look at other people's solutions. This is the gross way to do it. This is hard coding. This is, and I think they did this. Yeah, this is the correct solution. So they have alpha equals. Oh, that's interesting. So they did a list and the position of the list. So I did a dictionary. So, but this is even more clever because then it's like, so the position of alphabet And so they put it in order. So this would be 0, 1 all the way through. So they had to subtract 1 because indexes start at 0. So it's returning alpha, the index of that. And so that gets 1. But then they did this, and that's why people applauded it and said this. So then this, yeah, even more ways. Like, look at that. Like, oof. Position of alphabet, then this, and then you do this, and that. Oh, that is so. Yeah, there's so many little one-line zingers. And so if you want to become a medium level to advanced coder, this is what you look at. But anyways, we're getting way out too long though. That's a good video. We struggled on one, we did another. Let's do another video. All right, ta-ta until then.